looking strictly from a signature analysis standpoint, there's not much sense you can make out of it. It's the same as when you look at an executable. 80-90% of malicious executables are packed. Packed doesn't necessarily mean malicious. Same is to be said of obfuscated content. There's a lot of good websites that are using obfuscation. Safari books, a lot of copyrighted material. There's many, many reasons why you want to, in this day of age, paying a web developer $100,000 to develop a website, why you'd probably want to obfuscate that content. A simple measure to try to protect your information. So obfuscated malicious content, it's removing white space, renaming variables, renaming functions, adding anti-debugging measures, encoding values, multiple things to normally just scramble that code. Obviously on the malicious side of things, they're going to do a little bit more and try to add some anti-debugging measures. So once attackers started to do this, which is something that happened quite a while ago, the obfuscation response from many security companies were that they started to create simple JavaScript engines within their products. I mean, before they started creating their products, you probably heard that most of the researchers, myself included, started presenting on, JavaScript research tools that you could use, kind of variations of SpiderMonkey. SpiderMonkey is from Mozilla. You can tweak it to kind of have it dump out the deobfuscated content once you would implement various things that were missing. That was later taken, and security companies started taking SpiderMonkey's code as well as their own implementations of a JavaScript interpreter and putting it into products. The other thing that they would do, and this is very much similar to how packers for malicious executables were dealt with, is that they started looking at the deobfuscation algorithm. It's the same way with malicious executables. They started looking at the unpacker routine. Jump to the entry point, look for the unpacker routine. This might be something that it's FSG, it's mu. It's not something that's typically thought of as a good executable because it's packed with something that no good executable is packed with. Well, the security companies thought the same of many of the deobfuscation algorithms. Dean Edwards Packer is very commonly used. That's not one that would have a signature, but a lot of the custom algorithms that were used to create this deobfuscated content or obfuscated content and then deobfuscate it were targeted in terms of a signature. But for the most part, many of the simplistic JavaScript engines that were put in these products are easily bypassed. They just don't implement enough of the functions. And they have to keep up to day-to-day to act just like Firefox, just like IE, and most of those engines are not doing that. Simplistic first response, first thing that was really implemented from the attackers. So what did attackers start to do next? And this is what we're going to start to talk about, is where are we seeing the trend going up till we're going to talk about the next generation of how exploit delivery is happening. So the next thing that started to happen was multi-part attacks. So attackers said, fine, you're looking at the entire blob of content. In this example, it's not obfuscated. It's the same example as we saw at the beginning. But I'm not going to allow you to do that. It's too simple. You're looking at my deobfuscation algorithms. You do have a JavaScript engine of some sort. So you're not going to do that. What I'm going to do is I'm going to send a multi-part response. Multiple connections. So let's see what that means. So this is taken from an example of a live malicious page. It's a little bit of JavaScript. And on the top, it's not really obfuscated, but it's using some ASCII characters to make it look a little bit difficult for human reading. But on the bottom, I kind of remove those ASCII characters to make it a little bit simpler to read. And all it is it's dynamic creation of an iframe. Now, when a page has an iframe inside of it, that just instructs the browser to go and fetch that content. So you've made a separate connection after your initial content has come down. So the iframe that's fetched is, and don't go visit this website because it's probably still live, cu.org.cn. So let's see what's on that site. So we go to that iframe, we look at the content that would be fed to the browser, and that iframe then again holds more iframes. 123.html is one example of one of the iframes in there. Let's look at that. Go to that iframe. It contains, well, it's the same thing almost as a script, as an iframe. It's a script tag, and it's going to fetch 1 through 11.jpg. 11 separate files that it's including. It really doesn't matter what the extension is. The browser is going to treat it the exact same. So if you look at each of those files separately, 11 separate files, you'll see that each one of those contains a piece of the sum. So from the perspective of the content analysis engine looking in the middle, they're going to look at each separate one. But they're not going to look at it in total. This is a problem from, one, a JavaScript engine. So it's going to get var, let's look at the first one, it's one.jpg, var, and then that variable name equals 0, and they'll say, great, I don't really see anything malicious from that. And they're not going to have 2.jpg because it's a completely separate connection to really put the pieces together. And then 3.jpg. They have typically a gateway will have under 1 millisecond to analyze content. 1 millisecond. So they're not going to keep state, especially of separate connections that, for all intents and purposes, they have no idea that are related. So 1.jpg, 2.jpg, 3.jpg. 3.jpg is a little bit more interesting. It's obviously got a bunch of shellcode in there. A signature analysis engine would pick this up. The JavaScript emulator is really where it would have the most amount of problems. So this is somewhat successful if they perhaps don't have the right signature. Again, polymorphic obfuscation. This was not obfuscated, but breaking it up into pieces, absolutely successful as a first kind of step. So current techniques. All right, let's recap. Obfuscation, highly used. I would say 90 to 95% of all malicious web pages, what they'll do is they'll put an iframe, they'll compromise, hundreds of thousands of sites. We saw this with Gumblar, Beladen, 9ball. These are mass injections. Mass injections that either they were able to embed content on that site through some input validation that wasn't checked, or FTP credentials that were stolen due to infected laptop, had keylogger, same old scenario. But iframes are generally embedded onto that site, and finally the landing page in most cases is an obfuscated page. 90-95% of the final landing pages will be completely obfuscated. They'll make use of encryption. So as we saw before in the multi-part response, in many cases there might have been a key that would have been used in the algorithm that was included in a separate file. So there's several encryption algorithms that are used, especially in the multi-part, which is really what's used in the current techniques more and more, is breaking it up into multiple parts through an iframe or a script tag. But is there even more that attackers can do? So let's enter into Web 2.0. And Web 2.0 is a huge marketing term, but there's really a huge shift in the way everything is happening. It's more about the clients fetching content from multiple servers, servers retrieving content from the client. It's just a completely different way of how and where content's coming from and who it's actually coming, who's responsible for putting content up there. Gadgets, widgets, mashups, common terms in a Web 2.0 world, but it's a completely different technology. It's very much, as opposed to the Web 1.0 world, which is synchronous, click, wait, it's asynchronous. You have objects within JavaScript that you can use that are happening in the background, sometimes based off user actions, sometimes based off timers, but things are happening in the background. Content has been served down to the user, and multiple things can actually happen. And obviously we know from the mashups and gadgets, top 100 websites, almost all of them are one way or another using Web 2.0. So attackers in a Web 2.0 universe, when they are using any of these technologies, what are they using? So they've done a great job of exploiting user-generated content. You can right now create an eBay auction site, for example, which allows you to embed HTML in there. And if you've obfuscated it enough, you can actually embed an exploit in there. Create some simple auction with the best, choose your best product, best Xbox, sell it for $5 at Christmas, and you can actually create a malicious eBay auction. Anybody who goes to visit there, they don't have to buy it. They can actually